What do you mean? What do you understand by percentage? Per cent. Cent is 100. Percent. Per 100. Out of 100. If you calculate something out of 100, it is called percentage. Now, why? Why do we calculate out of 100? Okay, I'll tell you this way. A boy scored 90% in an examination and a girl scored 450 marks. Now my question is, let me complete, guys. What do you understand about this boy? It's very clear, he got 90%. So you have some idea about this boy, but can you comment on this girl? She scored 450. I said 450, right? Why? It is very difficult to understand, girls. Is it very difficult? No. I don't know, but the context is we don't know the maximum marks in this test, right? If the maximum mark is 500, she scored 450, then it is 90%. So what is missing here? Actual marks, there is no comparison, but 90% in comparison with some other number. So what happens? Even a layman can understand, right? You go to somebody, working in the gardener, you tell him that your aggregate is 75, he understands. But you tell him you scored 471, something like that, he can't understand. That's why it means data becomes more readable, easy to understand when you express in terms of percentage. If I say my profit is 20%, you clearly understand. I invested 100 rupees, my returns are 120. There is 20% profit for me. As simple as that. But if I say every month I am getting 50,000 profit, am I doing good or not? You can't say, because you don't know about my investment. I invested 1 crore and getting 50,000 every month. It's not loss. You can't predict, right? You can't understand. That's why we use percentage. Is it clear now? So, how do we solve problems related to percentage? The word itself says it is out of 100. So, we have conventional methods to solve problems. Basically, we solve problems in 3 different ways. It can be any concept. It can be percentages or any concept from arithmetic, quantitative aptitude. There are 3 different methods that we use broadly to solve problems. One is, we call it as technically, one is problem solving method. Analytical, logical. There are 3 ways to solve problems, right? I'll give you one simple example, one simple problem, just to explain you these 3 techniques. I don't say you can solve every problem in 3 methods, right? One of these 3 methods are used to solve problems. For example, a farmer has certain number of goats and hens. A farmer has certain number of goats and hens. If you count, if heads are counted, there are 200. If legs are counted, there are 580. Number of heads is 200. Legs are counted, there are 580. Now, Tell me how many goats and how many hens he has. A farmer has certain number of goats and hens. If you count the heads, there are 200 heads. If you count the legs, there are only 580. So how many goats he has and how many hens he has? A simple arithmetic problem. Very good. What's your name? Aruna. Aruna is very intelligent. She must be. Let's see how she solved this problem. Aruna, how did you solve? You can sit, no issue.
Hens has 2 legs. Hens will have 2 legs.
Yeah, hens, each hen has 2 legs, each goat has 4 legs.
Total let's see. Consider the total are the hens.
We are considering all of them are hens. How many are there?
200 hens.
How many animals are there altogether?
200.
Why 200?
200.
Because there are 200, it means there are 200 animals. So all 200 are hens.
So total number of legs will be 400.
So each hen has 2. So if you say all 200 are hens, 400, right?
So remaining legs will be 180.
Remaining is 180.
And if we consider goat, they will have 4 legs. So remaining 2 legs will be counted in 180. 180 by 2 will be 90. So total number of 90 goats and 200 minus 90 is 110.
Very good. This is called logic. Has anyone else solved this problem? Could you understand what she was saying? Could you understand? I'll explain it, right? Don't worry. Let us see some other methods. Yes.
I divide 100 and 100.
You divided it
100 and 100.
100 and 100. Good name? Neha. Niharika. Right. Now, hens and goats, 100 each. Very good.
Legs can be 400 and 200. I got total of 600.
Okay, here 100 goats have 200, 400. Each goat has 4 legs. So total number of legs is 600.
So I just 10 to the hens.
Okay.
110 and 90, then I got the 580.
Okay, what do you call this method? This is also a logical approach. You call it as hit and trail and error. Hit and trail or trail and error, right? So that is also a logical approach. So I am impressed. Has anyone solved it conventionally? What is conventional method to solve this problem? What do you mean by conventional method of solving problems? In conventional method, we convert the given problem into equations. We solve equations and we solve the problem. Am I right? For example, see the conventional method. I say hens and goats. I say there are X number of hens, Y number of goats. What should be X plus Y? X plus Y should be equal to? There are X number of hens and Y number of goats. So X plus Y should be 200. Each hen has how many legs? Then X hens will have 2X. Number of, right, legs here, and this will be 4Y because each goat has 4 legs. This is total number of legs. Now you got 2 equations, 2 linear equations in 2 variables. You can solve and find out. This is conventional method. Here actually the given problem, we are converting the given problem into equations. There lies the problem actually. Why you are not solving like this? Because the problem was with your learning in the school. Whenever somebody gives you two equations, you solve them quickly. But if it is a verbal problem, you don't know how to convert it into equations. Are you getting my point? So next time when we solve problems, you need to concentrate here also, right? If the trainer is using problem solving technique, so see what part of the problem he is using to convert to write equations, how he is writing equations, what is he comparing. After all, in entire quantitative ability, we use only 4 operations to solve problems. That's why it is called arithmetic: addition, subtraction, multiplication and division. You are very good at these 4 operations, but still fail to solve problems because you don't know when to add, when to subtract, when to multiply and when to divide. If you know that, you can write equations easily, right? So concentrate on that, how trainer is writing an equation or how he is comparing, why he is comparing, right? Adding or subtracting. Now there is another way to solve the same problem. For example, we use formulae or something that is already formulated, derived to solve problems, right? We use certain relations, pre-established relations to solve problems. For example, I ask you to calculate simple interest on certain sum of money, right? What do you use? Use a formula. What is formula for simple interest? You know it, you directly use it, right? Formula or any relation that is already there. How do you establish relations? If you want to establish a relation, we need to analyze, right? Analysis. After long analysis, we establish a relation between quantities. The same is repeatedly used to solve problems, right? That is called a formula or a relation. If you use any relation or a formula or formulae to solve problems, you call it as analytical method. Can we use any formula to solve this problem? Because you can't solve problems in this way, because somebody who is expert in this particular subject only knows about different relations that are already there and their application, right? We can use a relation here. There is a rule of alligation. This is applicable wherever there is a mixture. If you have a mixture of 2 or more ingredients, this alligation rule can be applied, right? Indirectly, we have here mixture of animals. There are 2 varieties of animals here. What are they? Hens and goats. So how do you apply this? We will be discussing this rule in detail in later sessions, right? So how many animals are there altogether? If I suppose all animals are of only one type, hens, then how many legs do I have? All 200 are hens, you have 400 legs. If all animals, all 200 are goats, you will have 800. What I mean to say is, if all the animals are of this type, this is the possible number of legs. All the animals are of this type, this is the possible number of legs. And one more thing, number of legs can never be less than 400, number of legs can never be more than 800, maximum and minimum. But on an average, how many legs are there? 580. So we have a mixture, right? If it were not a mixture, only one constituent, this should be the value, or this should be the value. But we do have a mixture. The mixture value is this. When you have these 3, we can find out in what ratio these animals are present in the mixture. So that is taking difference diagonally. What is difference of 580 and 800? 220, and here it is 180. Animal should be in the ratio 220, 180, or 220 and 180 is 400. We don't have 400 animals there. I am taking half of each. So there are 110 hens, and 90 goats. You can solve like this also, right? Now this is a more sophisticated method of solving problems. We don't use any we don't write any equations, or we don't use any relations that are already there to solve problems logically, right? That's how she was solving it. How she solved it? How many animals are there? How many animals are there? 200. Each hen has 2 legs, each goat has 4 legs. Now see how you can solve problems logically. Most of the times, 30-40% of the times, we can solve problems logically, right? See how to think. Each animal has at least 2 legs. Each animal has at least, am I right? They have either 2 legs or, but every animal has at least. Let us do one thing. Let us distribute 2 for all 200 animals. 2 legs for all 200 animals. So how many legs are distributed now? Total number of legs is, out of 580, 400 are distributed, 2 per each animal. The remaining 180. These 180 are legs of only goats. Why? Each hen has only 2 legs, and we have distributed 2 legs for all 200 animals. Whatever the remaining should be legs of only goats. How many more legs we need to give to each goat? 2 more. 180 at the rate of 2 per each animal. 180 can be given to how many? How many animals?
90.
So what does it mean? There are just 90 goats. That's how she calculated. Right? For this it is very fast, right? Very easy, fast, quick, right? Logical. So if you solve problems like this, it is called logical solving problems, right? So these are the different techniques. Now let us see how we apply these techniques in solving problems. Most of the times, 30-40% of the times we can solve problems logically. If multiple relations are involved, right, then probably we have pre-established relations, we will be using it, right? So even if multiple things are compared, there are many comparisons, right, then we go for traditional techniques. We switch between these 3 methods, right? Now here in percentages, the problems talk about, every problem talks about certain percentage or percentages. So for example, look at first problem. A trader bought some apples. 4% of them were spoiled in transport, 10% of the remaining got rotten, and sold 90% of good ones. If 540 apples remained unsold, find the number of apples that he bought. He has given us the remaining number of apples. After selling, he is left with few apples, 540. Right? We know this number, and we are supposed to calculate the initial number of apples he bought. So how to calculate? Before we go to this problem, first tell me, what is 15% of 420? How do you calculate certain percent of a number? For example, 15% of 420. 15 by 420, sorry. 15 by 420, 15 by 100 into 420 will give you that number, right? So what is 10% of 420, guys? 10% of 420. 10% is 42. Then what is 5%? Huh? How much? Then what is 15%? 42 plus 21. How much is that? So what is 15% of 420? As simple as that. Why are you always going for 15 by 100 into 420? Are you getting my point? Sometimes you can calculate easily, break up and calculate. break up and calculate. I repeat one more time. 10% is 10% of 420 is 42. 10% is 42. 5% is 42 plus 21. As simple as that. You want to try? Shall I give you one more example? Will you try? Tell me what is 8% of 725? And it is same again. 8 by 100 into 725, that is same. If you calculate, if you want to calculate like that, I told you what was my technique, what was our earlier technique? Break up and calculate. How do you break it up? See this, don't consider 10 minus 2 or something like this. Breakup can be done on both sides. You can break up either this side or that side. A% of B is same as B% of A, because A by 100 into B or B by 100 into A, both are same, right? A% of B or B% of A. So you can break it up on either sides. What is 8% of 100? 8% of 100. 8. 8% of 700. 8% of 100 is 8. 8% of 700 is 7 times 8. 7 8s are 56. 8% of 25. You don't know. What is 8% of 100? Listen to my question carefully. 8% of 100. 8% of 50. 8% of 25. As simple as that. 8% of 700 is 56. 8% of 25 is 2. So what is it? 56 plus 2. As simple as that. So I don't say it is always possible, but when possible, we have to take advantage. Are you getting my point? So you can break up and calculate, right? Always. It can be on either sides. Now shall I ask one more? Total number of apples he bought is 100. That's my assumption. I am assuming total number of apples he bought is 100. Good. What happened here? 4% of the apples are spoiled in transport. So transport 4%. What is 4% of 100? 4 apples. 4 apples got spoiled in transport. So he is left with how many now? He is left with how many? Very good. So the remaining are left with, right? You can say remaining is 96. Now what is next statement of the problem? 10% of total apples or 10% of remaining apples. So there are two possibilities here. The problem statement can be 10% of the total got rotten. Then we calculate 10% on 100. If the 10% is on remaining, we calculate on 96. So what is it here? 96. Out of this 96, rotten. What percent got rotten? 10%. What is 10% of 96? 9.6 got rotten. So what is remaining? 96 minus 9.6. How to subtract? See, there is a difficulty. I'll tell you technique to subtract. Whenever you have to subtract something like this, round it up. I'm rounding it up. I say this is 10. 96 minus 10. I subtracted 0.4 extra here. That's why I'm adding 0.4 here. As simple as that. I repeat one more time. I'm assuming I'm rounding it up to the nearest whole number. 10. 96 minus 10. 86. I subtracted 0.4 extra here. So the same I am adding here. As simple as that. So 96 minus 9.6 is 86.4. What is this 86.4? The remaining good apples. After subtracting rotten apples, the remaining, these 86.4 are the good ones. So what percent of the good ones did he sell? 90%. What percent of the good ones he sold? 90%. So 90% is to be calculated on 100 or this 86.4. So sold 90%. You want to calculate 90% on that? Need not to calculate. So what is the remaining? 10% remaining. Right? Remaining. Or this is nothing but what he is saying, good ones. Right? As per the problem, he says good ones, right? So 90% of the good ones are sold. So it means 10% of the good ones should be remaining. What is 10% of 86.4? 8 point. Forget about this. We need not to concern about this particular number. We are only concerned about this particular number. So when we assume total number of apples he bought as 100, he is left with 8.64 apples. But according to the problem, he is left with how many apples? 540. Now see my comparison. If 8.64 is remaining, total number of apples he bought was 100. Right? If 540 apples are remaining, what is total number of apples he bought? I am questioning. When we suppose total number of apples as 100, he is left with 8.64. So my questioning is, when 8.64 is the remaining, total was 100. So if 540 is remaining, what is the total? Because they are in proportion, right? Direct variation, right? So if this increases, this also increases. If I buy more, I will be left with more. If I buy less, I will be left with less. As far as these percentages, we calculate the same percentages. So 540 into 100 by 8.64. This is how, when they are in direct variation, this is how we calculate, right? So what is it? 6250. 6250. Could you understand? So this is top-down approach. We are starting with the initial number of apples and reaching the final and making a comparison. This is top-down. There is one more approach. Technically there are two. Being, they are computer science students, right? You might have heard about these approaches, right? Top-down approach and bottom-up approach. Huh? Probably in first year. Top-down, bottom-up. Now let us see the bottom-up approach for the same problem. In bottom-up approach, we start with the last value and reach the initial value. Here we are starting with the initial value and reaching the last value. Right? Our comparison is with the last value. There our comparison will be with the first value. Have you noted down? Whichever you feel comfortable, you can use that particular method. What percent of the good ones is sold? Guys, what percent of the good ones is sold? 90%. So you should be left with what percent of the good ones? He is left with what percent of the good ones? So 10% of good ones is how much? 540. If 10% of good ones is 540, I am calculating total number of good ones. 10% is 540, total means 100, right? So 100% of good ones, 5400. Is this the total number of apples he bought? No, this is not the total number of apples he bought. How did you get good ones? To get good ones, what did we do? What was the earlier step to get good ones? After removing 10% of the rotten, we calculated good ones. So what I say, this 100% is only 90% of the previous number of apples. Am I right? This 100% was only 90% of the previous, because after subtracting 10% we got good ones. So 90% is 5400. Now again I am calculating what is 100%. It means number of apples before subtracting 10% of the rotten apples. So 100%. 90% is 5400. 100% is what? 90 into 60. 9 6 are 54. 10 6 are 60, because direct variation, right? 9 6 are 54. 10 6 are 60. So 100% is 6000. Is it the total number of apples he bought? No. What was it? I mean, what did he do before this? What happened before this? 4% was removed. So after removing 4%, we got this number. So this is actually equal to what percentage? 96. 96% is 6000. Now question, what is 100%? Now you get original number of apples, initial number of apples. So what is it? 96 is 6000, 100 is 6000 into 100 by 96, which is 6250. 6 thousands, 6 sixteens, 4 25s, 4 250s, 25 25, 625, 6250. A coconut tree was planted 2 years ago. It increases at the rate of 20% every year. If at present the height of the tree is 540 centimeters, what was it when the tree was planted? The coconut tree was planted when? When was it planted? 2 years ago. What he says, its height increases every year by, or it grows, its height increases by 20% every year. After 2 years, what is present height of the coconut tree? 540 centimeters. What is asked here? What was it when it was planted? It means 2 years ago, what was the height of the coconut tree? Now, you tell me, how do you solve? Don't say X was the height of the tree when it was planted. No X is here. I told you. So instead of X, what do we take? Very good. Height of the coconut tree when it planted was 100. So first year, after 1 year, what happens? Its height increases by 20%. Very good. So new height 120. So after 1 year, its height would be 120 centimeters. Now 1 more year, what happens? Another 20% increase in its height. So new height is 140, right? See guys, its height increases by 20%. It means 20% of which height?
120.
Previous height.
Yes, sir.
Right? Not initial height. If you say There is 20% increase in my marks every semester. You calculate this 20% increase on the previous semester, not on the first semester. Are you getting my point? So here 20% of 100 initial height, this is 120, but here 20% on this height, at present what is its height? 120. On 120 we need to calculate 20%. What is 10% of 120? 12. 20% would be, so here you have only 20 increase, but here the increase is 24. So what is new height? 144. Now if present height is 144, 2 years ago it was 100. If present height is 540, what was it 2 years ago? Same comparison, same logic. The logic that we applied here, same logic we are applying. If you suppose it was 100 2 years ago, present it should be 144. So present is 144, when it was planted it was only 100. Present is 540, what was it 2 years ago? So calculate 540 into 100 by 144. How much is this? 375. This is one method. Now there are many methods to solve problems, right? I'll tell you one more technique here. That is, when you have this type of problems, you can always don't require to solve problems like this, right? There is one more way where you can solve problems just through options. You can check through options. How to check through options? What are the options given there? 320. Second option. Third option. 400. Right. Is asking us to calculate the height of the coconut tree 2 years ago. So these are the, one of them is height of the coconut tree 2 years ago. Increase it 2 times by 20%, you should get 540. Am I right? If you increase that particular answer by 20% 2 times, we should exactly reach at 540. Are you getting my point?
Yes, sir.
So what I do, instead of solving like this, I go through options. I increase the options 20% 2 times. Whichever gives me 540, that is the correct answer. But here the problem is, there are 4 options and you need to calculate for 4 times. Not exactly. If you want to check through options, there is a technique. Listen to me carefully. You may have 4 options or 5 options. The maximum number of trials required is 2. If you follow my technique. Right? It is. Most of the times you have options in either ascending order or descending order. There is a convention. Or if they are not in ascending or descending order, you consider them in either ascending order or descending order. Suppose you have 5 options. Never ever substitute extreme options. Never try with extreme options. Right? Where to start? Start with the middlemost. I try with this number. If I get 540, this is my answer. Right? Problem is solved in just one trial. That is best case. Worst case, I got 580. I got 580, but expected answer is 540. Do I move to my left or to my right? Definitely, this is smaller value, this is bigger value, suppose. With this value I got 580. There is no sense in taking even bigger values. Are you getting my point? So now these 3 are eliminated. Now these 3 options are eliminated. This is not the answer, and these two also can never be the answers. So now I try with this. If it gives me 540, this is my answer. If it also doesn't give me 540, then this is the answer. I need not to try again with this. Worst case, only 2 trials. Are you getting my point? So I'll show it here. See. When 4, you consider one of these two, the middlemost. So let us take 400. It is easy to calculate. Easy to calculate 20% 2 times, right? Because 375 it is difficult. So let us take 400. 400. What is 20% of 400? 10% is 40. 20% is 80. So first 20%, 80. So 480. Again we need to calculate another 20% on this. What is 10%? 48. 20%? 96. So 48 plus 96. 5. But what is expected desired answer? So if I go to my right, do I ever get answer? No. So with one trial we have eliminated 2 options. Those 2 are not your answers. Now which one we are supposed to try now? 375. So second trial, 375. 375, 20% increase. What is 10% of 375? 37 point. 2 times 37.5, 75. So add 75, 450. Am I right? Again another 20% on 450. 10% of 450, 45. 20%, 90. 450 plus 90. So this is our answer. Even if this is not equal to 540, then this should be equal to 540. You never have to try more than twice. Are you getting my point? So this is how you can solve. Now one more thing you should know, because this will be of great help in solving many problems. So let me tell you one more technique here. Because see, if you know different approaches, it becomes easy for you to solve problems. Say 100 is increased by 25%. What would be the new number? 100 is increased by 25%. What is new number? 125. Very good. Now I want my 100 back. I have increased it initially, but now I want to keep this number as 100 itself. So by what percent should I decrease it now? By what percent I have to decrease this new number to get my old number? So I have to decrease it by certain percent. Am I right? Definitely, to get 100, to take it back to 100, I need to decrease this particular number by certain percent. What do you think is that percent? 20%. Same 25% will give me 20%. Let us calculate what is there. How much you want to decrease here? 25. Out of, you want 25 to be decreased out of 125. Into 100 will give you percentage. Are you getting my point? We want 25 to be reduced out of 125. So that 25 reduction is what percent of 125? What is it? 1/5. 1/5 is nothing but 20%. So we need to reduce it by 20%. Now, why we increase it by 25%, but just we are reducing it by 20% and we are getting the same value? Because this 25% is calculated on 100. This 20% is calculated on a bigger number. Smaller number, bigger percentage. Bigger number, that's how they are getting compensated. Otherwise, 25% is an increase of 1/4. 20% is a decrease of 1/5. Its application is something like this. The price of a commodity is increased by 25%. Price of petrol is increased by 25%, suppose. By what percentage I need to reduce my consumption to maintain same expenditure? 20%, right? Same thing. What it means? If the price of a commodity is increased by 25%, your expenditure also increases by 25%, but you don't want to spend 25% extra on that commodity. Rather, you want to cut down the consumption. By what percent you need to cut down your consumption or reduce your consumption? This is how it happens. Suppose initially you are spending 100 rupees on petrol. Price increases by 25%. To get the same quantity you need to spend 125 rupees. But you don't want to spend 125 rupees on that, just you want to spend only 100. So what happens? You need to reduce 25 rupees petrol here. You are reducing your consumption, 25 rupees petrol consumption. So that 25 is out of 125, which is 20%, right? The same question may be asked, right? So remember, if 1/4 increase is there, 1/5 decrease, right? Or this can be generalized like this. There is an increase of 1 by n, a decrease of 1 by n plus 1 will compensate it. This is not only in percentages, right? A number of men, if number of men increase by 1/4, number of days will decrease by 1/5. For example, 12 men can complete a job in 20 days. 12 men can complete a work in 20 days. If number of men increase by 1/4, what is 1/4 of this? 1/4 of 12? 3. It means 3 more men are joining here. Number of men increase by 1/4, it means 15. Days will decrease or increase? By how much? 1/5. What is 1/5 of 20? 4. So 20 minus 4. 12 men take 20 days to complete a work. It means it is nothing but 240 man days work. 12 20s. 15 16s is also 240. 10 15s is 150. 6 15s is 90. 150 plus 90 is 240. Are you getting my point? So this can be applied everywhere. If there is an increase of 1 by n, a decrease of 1 by n plus 1, right? Decrease should be there to compensate the effect. Or if there is a decrease of 1 by n, opposite effect. There is a decrease of 1 by n, there should be an increase of 1 by n minus 1. What I mean to say is, the price of a commodity or the shopkeeper is offering a discount of 25%. Shopkeeper is, right? There is a discount of 25% on a particular product. Because of this discount, sales went up by 20%. They are giving a discount of 25%. Because of this, sales increased by 20%. What is the percentage change in the net revenue? Will he get more revenue or less revenue? He has reduced price by 25%. Because of that, 20%, there is increase in sales by 20%. It means 20% increase in sales means on an average 100 are buying this particular product every day, but because of this discount, On an average, how many are buying? As simple as that. Earlier he was selling it for 100 rupees. Now he is selling it for only. We can calculate it easily. This is something like this. Before discount it was 100. 100 were buying every day. So he is getting 10,000 every day. Now after discount he is selling it for only 75. How many 75s he is selling? 120. So right, see, 75 into 120. How do you calculate this? How do you calculate this? 75 into 120. This is nothing but 3/4, right? Calculate 3/4 of 120. What is 3/4 of 120? 3/4 of 120. 90. So it is 9,000. Because I am taking this 75 as, are you getting my point? 100 into 3/4 is nothing but 75. So when I see a 75, I calculate 3/4 of the number next to it, multiply it by 100. As simple as that. Are you getting my point? Was that clear? 430 is 120. 330 is 90. 90 into 100, 9,000. Right? Now, earlier he used to get 10,000. Now he is getting only 9,000. So what is his loss here? 1,000. 1,000 is revenue decreased by 1,000 out of 10,000 initial amount. 1,000 out of 10,000 into 100 will give you percentage change. Initial value, final value. Change by initial value into 100 will give you percentage change. Change by initial value into 100 will give you percentage change. So what is it? What is it? 10%. What happened? Decreased. His revenue decreased by 10%. The same thing. Here we can directly make out. See. Here he is offering a discount of 25%. So now he is giving it for 75. Because of this his sales increased by 20%. Only 20% increase was there. What is 10% of 75? 20% of 75? 15. 75 plus 15 is how much? 90. Initially he is getting 100 rupees revenue. Finally he is getting only 90 rupees revenue. So what happened to his revenue? Increased or decreased? Decreased by how much? So problems can be asked like this, right? You have this technique when there is decrease, increase, right? When these two are equal, you can use this particular technique. When they are not equal, this is how we calculate, right? Now what is next problem? I understand, that's what we were discussing. Even I am hungry, right? A software engineer just like you takes 10 minutes time to type 100 lines of code, whereas it takes 5 minutes to think of 100 lines of code, and to type the same 100 it takes another 10 minutes. A software engineer takes 5 minutes to think of 100 lines of code, and it takes 10 minutes to type the same 100 lines. After every 10 minutes of work, it takes a break for 5 minutes. After every 10 minutes of work, even thinking is considered as a work, right? So after every 10 minutes of work, he takes a break for 5 minutes. If he works like this, in 1 hour, how many lines can he type? It takes 5 minutes to think of 100 lines and 10 minutes to type the same 100 lines. But he takes a break for 5 minutes after every 10 minutes. He takes a break for 5 minutes after every 10 minutes of work. Even thinking is also a work.
300 lines. Break.
That's why you are software engineers, right? Huh? Is it so? $300 ఎలా వచ్చింది మీకు?
20 minutes 100 lines.
అబ్బా, first 5 minutes. So he thinks of 100 lines of code. So next 5 minutes
Type 50 words. Break.
he types 50 lines. Now next 5 minutes is break time. After the break he types another 50. Now next 5 minutes he thinks of another 100 lines.
Yes.
Now again 5 minutes break. After the break
90 lines.
he works directly for 10 minutes,
Typing.
types 100, then again
Break.
5 minutes break, then after the break
5 minutes. Think.
hmm,
5 minutes. Type.
hmm, 5 minutes
Type.
types how much?
50.
50. Now 60 minutes is over. So we can consider this and this.
Yes, sir. 250.
How much is this?
250.
What did you say?
300.
You said 300, right? Huh? So ఒక బ్రేక్ మీద ప్రాబ్లం ఇస్తే టైం ఎంత అవుతుంది అంటే ఎన్ని లైన్స్ వస్తే క్యాలిక్యులేట్ చేయమంటే రాలేదు. బ్రేక్ ఎందుకు మీకు? బ్రేక్ అయిపోయిన తర్వాత అడగాల. A man scored 42.5% in an exam, failed by 5 marks. If he scored 52.5%, he would pass by 15 marks. Then the minimum marks to pass the exam. First he scored what percent? So first time he failed or passed? Failed. Failed by how many marks? Next time he scored what percent? Failed or passed? By how many marks? Now, what is the difference between, what is the difference in the percentage of marks he got in both the cases? 42.5% first case, 52.5% is second case. So there is a difference of 10% in his marks in these two cases. Similarly, what is the difference in the marks he got in both the cases? First case he failed by how many? Second case he passed by. So what is difference in his actual marks? Huh? 20 or 10? Okay, you understand it better this way. Do you know number line? Number line. So similarly, this is marks line, right? I call this as pass mark. If one is pass, it will be to the right of this line. One is failed, it will be to the left of this. First case, what percent he got? So he failed or passed? So he will be here, 42.5%. What is this gap? he got 5 marks less than the pass mark. That is a shortage of 5. Now second case, passed or failed? By how many marks? Percentage is 52.5%. Passed by how many marks? Now, difference between these two is 10%, is equal to, what is this gap to this gap is equal to how many marks? 5 plus 15. What is this gap? 20. This gap is 10% or equal to 20 marks. So it is not 10 marks gap. The marks gap is 20. Remember, class was scheduled at 10, but many of you came late, right? By 30 minutes or 40 minutes or 45 minutes. Yes. For example, first day you are late by 15 minutes. So you know what happens when you come late to the class. So because of the consequences of your late, next day you are early by 10 minutes. What is time difference in these two cases? First day you were late by 15 minutes. Second day you were early by 10 minutes. What is time difference in these two cases? Huh? Class is at 10. You are late by 15 minutes. It means you came to class at 10:15. Second day, class is at 10. You are 10 minutes early. It means you are here by 9:50. What is gap between 9:50 and 10:15? What is the gap here? So similarly here, one case he failed by 5 marks. Second case he passed by 15 marks. So marks difference is not 10, it is 20. If both the cases he fails, take directly difference. If both the cases he is pass, then you can take directly difference. But one case is he fails and the other case he passes the exam, then you need to add both of them. Don't subtract, right? Similarly, if both are late, you can subtract. Both are early, you can subtract. But one late and one early, you need to add, right? So 10% is equal to 20 marks. Here, the different types of questions that can be asked. One is maximum mark in the exam. What is maximum mark? 100%. 100% is 200. This question can be asked. What is maximum mark in the exam? Or pass mark. This is called maximum mark. Or it can be asked as pass mark in the exam. Pass mark means 42.5% plus 5 marks. First case he failed by 5 marks. He scored only 42.5%. If he scores another 5 marks, right, he will get through the exam, right? So pass mark is 42.5% of the total marks plus 5 marks. Or 52.5% minus 15 marks. Because second case he got 15 marks more than the pass mark. 10% is 20. It means 1% is 2 marks. Right? Then 42.5% is how many marks? Double that. 85. So this is 85 plus 5, which is equal to 90. 90 marks is the pass mark. Or he may ask you one more question, the same problem. What is the minimum percentage of marks required to pass the exam? Pass percentage otherwise. Right? So 90 marks is nothing but 45%, because 1% is 2 marks. 1%, 2 marks is 1%. 20 marks is 10%. 2 marks is 1%. 90 marks is 45%. So he can ask you, so he has to score 45% or he has to score 90 marks. Right? That is how question can be asked. Next one.